Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Peace and blessings upon you all. Dear students, we have seen the context-free grammar, its derivations, then we see leftmost derivation, rightmost derivations, and now we see what's called as an ambiguous grammar. Okay, so by definition, a grammar that has more than one leftmost derivation for a single sentential form or has more than one rightmost derivation for a single sentential form is ambiguous. But having more than one leftmost and rightmost derivation is not important. Important is that we can say in a proper way the grammar is ambiguous if it has more than one parse tree for some string. Okay, so in nutshell, if we say like this, that we say a CFG is ambiguous, okay, if and only if there is some string W belonging to that language with the particular grammar such that, okay, this W has, I mean, at least it should have, I can say at least two different, we need to have different parse trees, and that too with respect to that grammar. Okay, so you need to have two parse trees, and then and only then you can say, okay man, this grammar is ambiguous. And this happens when we have more than one leftmost derivations and more than one rightmost derivations. Okay, now let us take up this grammar. Let me change my pen first. Let us take up this grammar, which has some production rules, that expression E goes to I, now E goes to E plus E, okay, and E goes to E star E, and E goes to parenthesis E, and there may be many things also. Let's take up this thing. Now let us take up a sentential form of E plus E times E. Okay, now if you look at it, this sentential form has two derivations, derivation 1 and derivation 2. Now derivation 1 will be like this, that we got a E and we try to derive it, and we say firstly we use E plus E, the rule number 2, 3 and 4. Let's take a rule number 2 first, okay, that is E plus E. Right, now this one will be derived further. We take up say for example because I want the multiplication, so I will use this E, derive this E, and use the rule number 3rd. So this E will be like this. Now this will convert into E times E, right, this guy. Okay, sorry, this is not D2. Now let me derivation 2 here. I will say E, okay, the firstly I will use a rule 3rd. I will not use rule 2nd. Here I use rule 2nd, this one. Now I will use rule 3rd first, that is E times E. Okay, and now I will derive this E and using rule number 2 to E plus E, and then times E. Now both of these guys are same, okay, they will have both of these derivations are to the same sentential form, E plus E times E. Now this is equivalent of saying that we have got two parse trees for this. If you look at it, we've got two parse trees. Okay, firstly the E, then I use it firstly the E plus E, okay, then I derive from this E that E times E, and what I got it, I got then if I convert them into the IDs later on, okay, then this will become, I'll convert this an ID, this ID and this ID, let me add up here also the E goes to ID, whatever. Then if I use leftmost, or I can use rightmost, whatever I will get this thing. I will get this ID, then I got plus, then I got this ID, then I got multiply, and then I got this ID. So this is ID plus ID into ID, or the E plus E into E is one of the same thing. But I can do it in a separate with a different parse tree altogether. So here I use first E times E first, not the plus, and then I derive this E into E plus E, right? And then I can convert this into ID, this ID. Derivations, we know we have done it. ID. Now this gets ID plus then ID times then ID. This is same ID plus ID into ID, or E plus E into E. So the same sentential form but two different parse trees, right? I repeat here that this is not the several derivations which makes it dangerous, but it is the existence of several parse trees that actually ruin this grammar. And we can say, hey, this grammar is ambiguous. Why? Because we got more than one parse trees in it. Let's take another example, and let me write the grammar again. So I say the grammar was E expression. So we say either it's an E plus E, or I could say like in the shortened form, E times E, or it is the parenthesis E, or it is the int, right? Or ID. Okay, let me call it an int or ID, whatever you like. Now we got strings. Say for example we got two strings. One of the strings I did decide on the top side, that is int into int plus int, whatever, or I could int plus int, or ID plus ID, whatever, AB plus B plus C, whatever you say. Now, like we did upside, this string has got two parse trees. Firstly, if I use the E plus E, or in this case I also use the E plus E, then I try to use the left E and make it E plus E, okay, and then I say int and int all, and in this case I will use the right one. So this is the right derivation, and this is the leftmost derivation, the rightmost derivation. But if we see in the previous example, we see leftmost derivation in the last video and rightmost derivation, they lead to a same parse tree. But here it doesn't lead to the same parse tree. It leads to the different parse tree. This is the different parse tree, right? This is different. Okay, and even though it says int plus int, and in this case also int plus int, the same string, both represent the same string, int plus int, but two different parse trees. And this is the leftmost done with leftmost derivation. This is done with the rightmost derivation, which we did in the last video also. But the important point to note is the parse tree was same in those cases, but here the parse tree is different. So if I again use this thing to show it clearly, because I'm not good in writing, int into int, okay, you are having multiplying ints together. Now if you look at it, this one also has a two parse tree, which I just shortly I have shown it, but it's a little bit properly shown now. For example, here I use the E plus E, or here I use the E star E. So one production rule, you do another production rule, then you do the leftmost derivation to this E, and you say E star E, and okay, in this case you do the right derivation, then E plus E, and finally you put up the ints there, and now you have int into int plus int, and in this case int into int plus int, the same string but two different parse trees. So if we see these guys, there are a couple of problems we see, and to remove these problems we actually don't have any algorithm. We should keep this thing in mind. There is no such algorithm for resolving ambiguity. In a sense, we say that automatically deriving an unambiguous grammar from a given grammar. Even we don't have an algorithm for finding whether the given CFG is ambiguous or not. There are, however, several ways to handle ambiguity. and the most direct method is to rewrite grammar unambiguously. Okay, but the problem will be that we are making the grammar more complicated. So let's try our hands on this. So what's the problem in this? Okay, we have two parse trees, but if we see here, we got what's called a left associativity of plus. That means if I wanna do this e plus e, before I can evolve this thing, okay, evaluate this thing, I mean we have to first evaluate this e, right? Okay, when we are here, we go on evaluating these two guys, and then we got the answer from these two guys, e this plus this, and then we can add it with this side, right? And this is the way we do it in the programming or in mathematics, because the pluses are left associative. But if you see here, before you start evaluating these two guys, you have to first evaluate the right one, the right e, and this e have to be evaluated, and for that we're gonna do these two ints plus of these two ints, and then we can do this int, right? So in second terms, this guy is doing, say for example, got int, we say plus int plus int, but it's doing firstly adding these two guys and then this one, and this one has an int plus int plus int, but it is first adding these two guys, then this plus is added with this int. So this is not right, because pluses are left associative. So we should do something to allow only this parse tree, and we should not allow this parse tree. And what about this guy? If we see this guy here, here is the associativity problem. Okay, the problem was of associativity, and here the problem is of precedence. Who will be evaluated first, plus or multiply? If you look at this, let us look at this first. I am having multiplication. Before I can do this multiplication, I have to evaluate this e, and before this, so I mean I have to do first plus. So this is happening like this, that I have to do e plus e first and then multiply it with the e, right? It's doing this thing, but it should not have been like this, because in programming we know the multiplication has higher precedence than the plus. That means it should do first this one and then this thing. That means if I go here and I see e plus e, before I can do this, I have to evaluate e into e. So multiplication is to be done first. When I do this, when I'm done with this, then I can do plus with this. So so this one is correct, because it gives more precedence to the multiplication than plus. So if you look at the parse tree, we say that the guy with the more depth will be done first, and the guy on the top will be done later on. So we got to do something so that it will fix the associativity as well as the precedence problem, right? So we saw there's a problem of precedence between multiplication and plus, and there is no grouping sequence of operators. For example, we should do it e plus e, that is the right associativity or left associative, and we know plus is left associative, so we gotta fix it. And we know the multiplication has more precedence, so we gotta fix it. So how we fix it? We try to rewrite a grammar in an unambiguous manner, right? So we had a grammar like this, which says e plus e into e, e and int. So we try to have more variables. Okay, now, so for example, I will say a grammar, I will write it, the above grammar, to e derives e plus t, okay, and then or t, simply it could have the t only. I can write it here or more, so that it will look more precise. So put it here. Then t, I will have t multiplied with the int, okay, or it can have directly the int, or it can have the e in parentheses. So if I write it like this, I'm rewriting a grammar. So this is the unambiguous grammar, which enforces the precedence of star over plus, and enforce the left associativity of both plus as well as star. So if you try to see how I will have a string, let's put up my string here, which was like int times int plus int. Let's write it here back. So we had int times int plus int. Now let us try to use these production rules to make it. So firstly, I have to say I have int into int plus int. So I have to use the start symbol e, okay, and the start symbol e does not have a multiplication in it, it has a plus in it. So this is a plus, okay, mind you, this is a plus, and multiplication is here with the t. So because I have to use a start symbol, so I can't use a multiplication in a first level. So that's why I say that I have to go the more precedence on the downside. So I have no choice but to use e plus t. That means I go now on this side. And if I don't have the pluses, that I can use the t simply. Maybe I have multiplies only, so I can use a t only at that moment, and then I will derive the t. But here I have no choice but to use e plus t, so I will use, let me draw the direct the parse tree. I have an e, okay, now then I can use e plus and t, because I got no choice but to use this, right? Now I can go e and I can go to the t, okay. If you say either the left derivation or the right derivation, if I use a t, okay, now the t can go to the t into int, t can go to the int, and t can go to the e itself, right? And if I see my expression int into int plus t, I want to have the multiplication, so I will go left way, leftmost derivation, and I start evaluating e again here. And for e, I can't have a e plus t now, I will have a t here. Let me drive it to the t, okay. Now this t will be derived, and t is here, t into t. I've got t into int, sorry, right? Okay. Now later on I can go to the left ways, so this t into the int, I could have done in a right derivation, rightmost derivation. In that manner also I can get the same thing, and here this t goes to the int now. Now I got the int into int plus int, right? I got this thing, right? Okay. Now I can't actually do it otherwise. I can't do it like this. E goes to, say for example, e times e, which we were doing last time, right? Because e times e first, and then I could have gone here e plus e, which I did last time, and then ints and ints, where the plus has got more precedence. It's an down at a depth, so this plus has got a higher precedence than multiplication. This is totally eliminated, because we can't have a choice. We don't have a choice here, because e does not have a multiplication, but it has an additional variable t. Once you are done with the e, then you can go for a t. That means t will go down automatically, so it will have a more precedence now, right? So we can fix this thing. What about the associativity? If I have like this, int plus int plus int, okay. Now if I use the e, what can be, we have a pluses there, right? We got an e plus and t, right? Okay. Now I need pluses, okay, because I have a pluses only. Now can I have a from this guy, because if I can do the right derivation and get the pluses from this side, that has got a more associativity, or that will be right associativity, but I can't do it because t does not have a plus. If I see my rule, t does not have a plus, t has a multiplication, so I can't use another plus get another plus from the t. I have to get the plus from the e only. So that means I have no choice but to evaluate from the left, right? So I have to go from this side and say e plus and t, right? Okay, then on this side I say e will go to the t and t will go to the int. This will go to the int and this will go to the int. So I will have int plus int plus int, and this is before evaluating this level. I have to evaluate this level right here, and before doing this I got to before doing this I got to evaluate this int first plus with this int, so left associativity. So this is also fixed, right? So you can have now many strings or sentential forms, and you can have a parse trees which have a single parse tree. Now I can't have another parse tree. I don't have choice to have another parse tree now because the right associative guy, this guy, is gone. I can't first e plus e, then because it is a t, so I can't do it this t into the e plus e. So I have no choice but to go from this side. Okay. Now, this ambiguity is common in the programming languages, not only in the arithmetic expression which we are discussing, but also in the if-then-else constructs. Let's try our hands now on the if-then-else and try to see how what kind of ambiguity is there, how we can fix it. Now consider this grammar. It says s is derived to if e then s. So if something true or false, then this, and other thing is which has an else part also. If e then s and else s. That means if true, then do whatever, and else do whatever, something else, right? Then else do s. Okay, so this if has got an else part also. This if does not have an else part, and there may be others also, and this grammar is ambiguous. Now say I got an expression like this. Say for example I got an expression if some expression e1, maybe this may be true or false, then and then I say if e2, then do the something else, then do something like s3, else do the s4. Okay, now I'm saying if e1, okay, if some expression 1 is there, then in the then we have an dangling if, because the dangling if else problem. In the then we have again an if e2, then do s3. Now this else s4 is a problem now, because this else s4 can be with this then, or this else may be of this then, right? Because when a C we say if you see a C program, if you do something, then do this, then you do else, you do this, right? But here I got an if, okay, statement in itself, and it may have an else. Okay, now in the C we have the parentheses which actually tell us exactly which else belong to which if. Okay, now here when I have a string like this, tokens coming up like this, okay, then I may have a problem. Is this else belonging to this then, or is this else belonging to the parent then, right? So if we try to draw a parse tree of this guy, so we can say like, hey, it could be like this, if and e1, then there is also the if, then you got to do s4, okay, and this if has e2, then you do s3. That means if e1 is true, then you got an if inside, and which has its own, if that is true, that's going to E2, otherwise it will do the S3. Okay, else of this it will go for S4. But if I write it another way, if E1 then do if, now if E2 then do S3, and else is with this if. So I can have the problem of else S4 with the inner if, or S4 else S4 with the outer if. Now we got two parse trees, so that's why we say this is an ambiguous grammar. Now this ambiguous grammar, and if you see out of the two, we prefer this one. Okay, we want so this is a fix also to this problem, that we say that else part matches the closest unmatched then. So that means S4 has a closest unmatched then is this then, right? So it should match to this then. Okay, now let's try and understand why this the dangling else has a problem here. Because this else has a problem because we want to see, does this match to the inner if, or does this match to the outer if, right? So simple thing is to disallow it. So how we do it? So let us try to comprehend this thing. Now if we have, say for example, if something, okay, and then something. Now it never have a problem because we don't have an else part here, right? So we don't have an else part here, so it's not a problem at all. Now problem comes, say for example we have if whatever then, and in the then part we again have an if. Okay, now this if it does not have an else, if then it does not have an else, and we have an else here. Now question comes, is this else belonging to this then, or is this else belonging to this then? Okay, now if we had like this, if say from some expression, say E1 then do something, do E2, then I say if E3 then do the E4, else do the E5, and then again say the else do the E6. Now question, see here, if then is up to this thing, and this guy got if then and else. Okay, so we got an else attached to this then, and then we have again an else, so there is no problem. This else will belong to this then, as simple as it is, because internally if then else, it is matching. Okay, so if this if has an else, so it is a matching if. Let us call it a matching if. Now this is the matching if. Okay, now matching if it is matching if is inside, okay, and then we have an else, then we don't have a problem because this else will match to this then. Okay, so that means this itself will become a matching if, is it or not? So we say if some expression, then if there is a matching if after the then, and else does not have a problem. Okay, else does not have a problem because after that whatever it is, but I should have a matching if again, because it will have recursive effect if it is like again if else then and without the else part. So like this structure, if that structure is here also after this else, now that will create a problem. So I should have a matching if again after the else, so that there is no ambiguity in the else part, right? So either I should have an if then without an else part. But what about if I have if some expression, say for example expression 1, okay, then okay, I got an expression 2, but in expression 2 what I have an if itself. Okay, if, but let's say this is a matching if, MIF, this is a matching if which has its own else. So this matching if also it has an else inside. Okay, here. Now this then will have an else here. Okay, what about this else now? After this else, if I want the, maybe if I have say for example if and then, okay, that means unmatched if, which does not have an else, it still will not create a problem. Why? Because if it does not have an else, we don't care, because this else will not be a problem, because here we had a matching if. If you're not getting properly, let me do it in another way. I'm saying if I have an if and then, okay, and I don't have an else part, then it's not a problem, okay. But if I have inside now this then if statement, and this if then else, it has if then else, okay, and now we have an else here of this guy, so it is not a problem, because we got a matching if here, we got a matching if which has its else and then part together, so it is not a problem. This else will not be a problem, because I will not be having a doubt whether this else belongs to this then or this else belongs to this then, because internal one is complete, okay. So it is a matching if. So if it is a matching if and I have an else, so I don't have a problem. Now here in the else part, I can have two situations, whether I could have a matching if or I have a simple if. So matching if will have its if else then, okay, if then else, or it could have if else only. So I don't have a problem, because both of these can be here, because this else is no more a problem now, right? So this is what I want. I don't want this else to dangle. I don't want this else to have an ambiguity of mix-up. Okay. So what I say is that I am only trying to do one thing, that I am trying to cut off unmatched if from this situation. I don't want unmatched if here. That will give me a problem. If unmatched if is in an else part, that's not a problem. So I say if then, if here is the matched if, I don't have a problem, and else, after this else I could have a matched if or I could have the unmatched if. That is not a problem, right? The problem is if I have if then and I am having here the unmatched if. What does the unmatched if means? I have an if then but not an else part with it. Then when I have an else, I will have a confusion whether this else goes to with this guy or whether this else goes with this guy, with this then or this inside then, right? And here I can have matched if or unmatched if, right? So this unmatched if is to be removed, which is inside this then. So if at all I want to allow the if here, if then, and it should have its own else, then it should be matched if. Matched if is someone which has its else then together, right? And if at all I have to use unmatched if, then it should be in the else part. Here if it is matched if, that's not a problem, because matched if will never give a problem, or if it is unmatched if, no problem, because unmatched if here in the then portion will create a problem. So that is to be removed. That is unambiguous. So how I do that? So I will try to rewrite my grammar. So what I'm trying to do is else matches the closest unmatched then, okay? Because I would say if this is the else, it matches the closest then, okay? Closest unmatched then, because this then is still unmatched. So we can now, if you have two else's, here is else, here is also else. Now should this else be with this then and this else also with this then? How we do that? Because else will match to the closest unmatched then. Now this is else, you try to match it, it matches the closest is this then. So this then becomes now unmatched. Now this else will try to with this one, because this is matched, so it will not go. It will try to this then, because this is unmatched now, and this else will match with this then, okay? So how we describe this in a grammar? So the grammar will be like this. We will have, so we say hey S will have either the matched if or it will have the unmatched if. So what is the matched if doing? All thens are matched. What does that mean? That every then has its own else matched. unmatched if, some then are unmatched. That means our thens do not have else's, but we don't have a problem with those guys if they are in the else part. But if they are in a then part, then it is a problem. Yeah, getting? So we say if there is a matched if, it can be derived to if e expression, then, okay, let me write it, and else, okay, here. So if we say if it's a matched if e, then here I don't have an unmatched if, I should have the matched if. Else, because I'm talking about matched if, so let it be matched if. And there is also some other expressions if there are, no problem. But if it is an unmatched if, so it could have if e, then s, and it has missing that else part, no problem. But yeah, if it has the else, if e, then again if it has an if part, then it should be matched if again with the then, always matched if. Else it could be the unmatched if. Okay, if unmatched if is there, unmatched if is that guy which does not have an else attached, so that can be in an else part only. And here in both cases, after then I'm having only matched ifs, right? So I'm eliminating, I'm actually removing the dangling else problem. Is it or not? So if we have now our that above expression, that expression which has the problem of ambiguity, if I say if e1 expression 1, then if inside, then we have if e2, then s3, else s4. It is writing, let me write it in this way so that it will become proper. If e1, so if we have an if e1, then you have its then, okay, but inside then there's again an if e2, then it has its own then, and then it has the else s4. Now question is, will this else be with this then or the upper then? Now with our grammar there will be no confusions, because we can't allow the unmatched if. Now look at it. Now if even, okay, then if e2, then else. So this else will go to the closest unmatched then, so that means this guy. So we inside the then we cannot allow, okay, we are not gonna allow the unmatched if according to our grammar. So inside this then, if you look at it here, inside this then we are not going to allow unmatched if. So if it at all it is there, it is the matched if. So that means according to this grammar we gonna have like this situation. So it is an if, and it has an e1, if e1, and it has again the if, okay. So if e1, again the if inside then, right? Then in if we have three guys. We have e2, if e2, then part, then s whatever that was, then I forgot here, then it should be something s3, then s3, else s4. So it is, this is the if part, this is then part, this is else part. So that means I got the if, this is the matched if, okay. Now matched if got e1, and sorry, this is the unmatched if this time because I don't have an else part. Now inside I have a matched if, so I have an like this, I have the unmatched if firstly, which has if then, and without an else part, this part I'm saying if e, then inside of the matched if, and I can have the else part also in it, in them, if I got a matched if inside, right? And this guy, if e1, if s4, that means if e1, okay, then if e2, then s3, and s4 with this guy is totally removed. So this dangling if problem is now solved. This is a diagram from the Dragon book. This gives a little more expressive way of showing things. So we say that if we have this problem, So the below parse tree is actually eliminated, where the else is the part of the then, upper then or upper if, and here else is the part of the lower if, okay, inside inner if, right? So we are disallowing this thing. How? Because we don't have the unmatched if inside the then, okay, and we have the matched ifs. That means else with the then, that's matched if inside the then, okay. This then can have only inside the matched if, which has its else part. So that means this else can only go to the if part, this if, which is its matching pair, right? Unlike this, where inside this then I got the unmatched if. So I will disallow this by the grammar as I said above, this grammar, because I have the, let me show it in a proper, look at here, that if I have a matched if and unmatched ifs, and a matched if, I have if, then inside if I have inside then I have only the matched ifs, and after else also I have the matched ifs if it's a matched if, and unmatched if I either the else part is missing, or if there is an else part, after the then I have only the matched ifs, and if at all I have an unmatched if, that has to be inside the after the else part, right? Okay, I think that's all for this. We can deal with more examples and all. So let's do that in the next video. Until then, ma salama.